Otherwise, I'd love to have it playing more because I think music, as long as it's not where it's taking me out of my element, it helps. There we go. I really wanted a summary. There we go. Music can either be a good thing or sometimes music can detract from our ability to think and concentrate. And, when we're young, it's very easy to say, well, I need music in order to do this, even though music might be something that distracts us. And some kids will use music as a out, as an excuse, like I can't do anything without music. And it's kind of like selling yourself short. I need this in order to do that. um and we're if we don't like math, or if we don't like doing something, we're going to use any excuse we can to find to get out of that. And it's where, in other words, our brain is telling us, like, I need everything perfect in order to do this very hard, difficult task. um and that's something that we have to learn to overcome. And things don't have to be perfect, and in fact, I truly believe that things can almost never be perfect. A lot of people think, like, once I get this part of my life figured out, things will be better, or once this important thing in my life happens, then I can live and breathe easier. And so much of life is just doing your best every day through difficult circumstances. So you have to, my mother calls it muddle. You have to muddle along. And then eventually, if you have a good attitude and if you do your best, even though it's difficult, you wake up and you've accomplished some things, and you've surprised yourself, and you did things you didn't think you were capable of doing. So, okay. So radicals, I feel like this can be really hard for kids, especially if you struggle with multiplication tables. So, some students, they did their multiplication tables, maybe they had a little bit of success and they love doing the multiplication tables because, they found success with it. And so they practice more, and now multiplication is easy for them. And maybe some kids, tried multiplication tables and they struggled with it and they didn't like it. And so they didn't practice more because it was painful. And now we're in high school, and all those years and years of practice or not practice is all of a sudden coming into play. But it's okay. Everybody's journey is different. And you don't need to be perfect at this in order to have a great life. And, what we're trying to do is we're trying to teach your brain to think and to learn. Okay. All right. So overall, we are skewed to the right, where we're more confident about it. That's good. I would never expect anybody to feel super confident about it, especially if this is your first year dealing with this. What I would say is, you're gonna, like, so what we started with was simplify radicals. And then from simplify radicals, we went to adding and multiplying and dividing, and then we're going to solve. And the foundation is simplification of radicals. And so if you are struggling with simplification of radicals, it's going to make multiplying and adding and solving way harder. And so take time to go back and practice the simplification, and just do, 5 to 10 minutes every day, even at the expense of finishing the assignment for solving or for multiplying and dividing. Because, if you don't have that foundation, there's very little point in building on top of it. So if you're at the point where, that's where you need to put your time into, then put your time into there and send me an email and say, Mr. Brooks, I just spent extra time practicing simplification today. And, I didn't want to work 4 hours on my homework assignment. And I want to, if I understand your journey, I'm going to try to give you credit for that. Okay, so hopefully that makes sense. The 1, 4, 9, 16, these are perfect squares. So somebody up top got it, perfect squares got it, perfect squares got it. And it's always good to have the same vocabulary where if I say something, you guys understand what I'm talking about. And so the vocabulary and the language we speak is so important in our world today when, I'm going to go ahead and say it, when we're so divided. And so having the same language is so important. So yeah, these are the perfect squares. And when you simplify, you can only use perfect squares. It doesn't make sense to break down numbers without a perfect square. And then, oh, I screwed up this question. This was supposed to be open response. So there you go. When you multiply radicals, what I want you to do what I want you to know is you have to multiply the outside number times the outside number and the inside number times the inside number. And, a lot of students, it's actually a very easy process, but it's very easy to say, well, it's very easy, boom, I did it, I'm moving on. But it's new for some of you. And if it's new for some of you, then even though the process is easy, you still have to put effort in order to put it in your mind. And, some of the stuff is really easy and you can recognize a pattern. But you still need to put the effort to make it where that stays. Okay. Like over here, I was doing homework with my second grade son last night, and he was rearranging math sentences. And instead of doing the actual work like counting up to add, he would just find the pattern. He said, you just move this number from this problem when it's plus, and you move it over there when it's minus. And then, same thing, like you can reverse them to change it. And so instead of doing math as counting, he did the math as finding a pattern in the worksheet. And, it is the worksheet, but it's also like, when you rearrange math sentences, it is truly a pattern. You move a number and then it just swaps. And that's, I'm okay with that. I'm okay with him doing it that way and not counting. And the same thing with this. I hope that you guys see the pattern right here. When you multiply the denominator, I hope that you don't say like, well, I have to multiply the square root of b times the square root of b. The pattern is you just take the number on the inside and poof, the radical goes away. And so, instead of working harder with this, I mean, you can always multiply, that's true. But if you just see the pattern, then you can work that way. I think that's great. Okay, so then some people are going to multiply it out, and that's fine. Okay, let me hear a show of a vote. Okay, yesterday I posted the video of multiplying and dividing radicals, and I posted that not early in the morning, but I posted it in the morning, and that was for the last Delta Math assignment. How many people here need me to go over that today, and how many people don't need to? So either say like, yes, I need multiply and divide instruction, or no, I don't need multiply and divide instruction. And you can make it private if you want. So right now in the text chat, and you can even tell me like, hey, I watched the video and it made sense, or hey, I watched the video and it didn't make sense. Okay, so, all right, there's one person. Okay, there's another person that responded. Okay, so Emily, can you clarify no to going over that skill, or no, it didn't make sense? Same thing, Haley. I'm guessing you're saying no, you don't want to go over it again. You're ready to move on, unless you tell me otherwise. I haven't watched the video, but yes, I can. Okay, so figure it out. All right, I should have a few more people responding here. All right, well, what I'm gonna do is I'm gonna, okay, so I've got a few people that did respond to dividing. So I'm just gonna talk about dividing. I'm not gonna talk about multiplying. But I'm gonna do one for dividing, okay? And I'm gonna go back to this. And when you guys divide, most of the time it's just, well, sometimes you'll have problems. I say most of the time. There's many occasions where you'll have problems where all you have to do is just, simplify the radical. But you need to know that you cannot have a radical in the denominator. So right now, just focus right here. This is the original problem. And it's going to give you a problem that looks like this. And you have a radical in the denominator. And you need to tell yourself, I'm not allowed to have a radical in the denominator. And so what we do is we call it realizing the denominator. And it's called realizing because when you take a square root of a number, that is not a real number. It's irrational. And not every square root is irrational. If you have the square root of 4, that's not irrational. That is 2. But if you have the square root of 2, let's say square root of 2, then this number, it's 1 point, like, what is it? If you're in your calculator and you do the square root of 2, which comes up a lot in geometry, you have 1.4142, and then it goes on and on and on and on and on and on and on. It's just like pi. It goes on forever. So it's not a real number. It's irrational. And so they call it realize the denominator. And so we're going to have to take that away. And what we're going to do is we're going to multiply. This is the process right here. So the original problem is a over square root of b. The way to do it is to multiply by square root of b over square root of b. And this is, again, just 1. It's not changing anything. This is just another way of saying 1. No matter what, any number you divide by itself, it's just 1. And so when you multiply by 1, it doesn't change that value at all. It doesn't change the original a over square root of b. It just rewrites it in a different way, okay? All right, hopefully that makes sense. And let's try just one real quick, and then we'll move on. Okay, so like this one, okay? So this is A is, there we go. So come on. Thank you. This is A is 60 and B is, oh my God, my handwriting looks like my son's, 10, okay? And so we're gonna multiply by the square root of B, well, the square root of b divided by the square root of b. I wrote it opposite because I always do the denominator first because that's the number I'm looking at first. So I looked opposite of the way I said it. And when that happens, again, the pattern, you can multiply this out, outside times outside, inside times inside, but the pattern is just to write down b. It's always going to be that way. The square root of anything squared is the number. And then this is going to be 600. And then from there, you simplify the top. So this is going to break down into 6 and 100. So it'd be 10 root 6 divided by 10. And then when you get here, this is where your algebra comes in. You can't simplify the numbers inside the radicals. You can't reduce a fraction using the numbers inside the radicals. You can't. So like, for example, this would be not allowed. Okay, you can't handle the number inside the radical with the denominator. But what you can do is you can handle these numbers right here on the outside of the denominator. And 10 divided by 10 is 1. So it's 1 root 6 over 1. But you don't write those ones, right? We don't, if it's over 1, it's just the number. And if there's a 1 in front of the radical, we don't write it. So it's just root 6. Yeah, that's right. Okay, All right, so there's that. And not a lot of people said do that. So hopefully that made sense to a few of you guys that wanted that. And if you need more help, then stay after and I'll be happy to do more with you. Okay. All right, and so let's move on right here. And I need to make an announcement before I forget, because of course I'm going to forget. And the announcement is that tomorrow we don't have a scheduled class, but we have to meet at 8 a.m. So we're going to meet back here in this Zoom at 8 a.m. tomorrow, and we're going to talk about mental health. And I'm going to talk about it a little bit, and then we're going to watch a video. And it is required by the district. I think it's a state requirement. So everybody in the state is going to do this, and everybody in Rock is going to do it tomorrow. And so we're going to meet back here at 8, and I'm going to talk a little bit. And I know I've dealt with a little bit of this. Well, I've dealt with a lot of trauma with kids in my life, and I've dealt with a few suicide situations. So it is very personal. So if you want to prepare yourself for that, but it's good to know, and it's good to know how to talk to someone who is thinking of self-harming or thinking of hurting themselves. And it's very important that we give ourselves the opportunity to intervene in that direction. So tomorrow at 8 a.m., set your alarms, and we'll come right back here.
Laura's gonna call them individual.
Yeah, if you don't show up, people will come after you. Okay, Miss Culver made that joke. All right, any questions about tomorrow? Good. Okay, all right. So today's learning target is I can solve equations using square roots. Okay, and I want to start here, and I was running around like crazy, so I'm going to start here. All right, let's say that I am thinking about the rules of algebra just strictly from the rules version. So I'm going to talk about why it works. Okay, so I'm going to make a table, and I'm going to put the operation and the inverse operation. And remember, we use inverse operation to cancel. So somebody tell me one operation that we use. There's 4 we started out with. Can somebody tell me one of the operations, or am I going to start? You probably like, what the heck's an operation? Okay, so I'll start. I'm going to give it to you that it's 8 a.m. Like multiplication. So if I say multiplication, what's the inverse operation of multiplication? How would you cancel off something? Emily Wilson, what's the inverse of multiplication? Division. Thank you, Cheska. And then if I said addition, what's the inverse of addition? Go ahead and type it out. Subtraction. Thank you. All right, so we understand we're supposed to use the inverse operations. So subtraction. And then we had 4, and of course it's just the inverse, right? If we have division, then obviously it's multiply. And if we have subtraction, obviously it's addition. Okay, now I'm going to add a 5th one, and it's one we've already dealt with, and that's square root. Okay, so if I have a problem with square root in it, what do we do what's the inverse of a square root? All right, if you know it, you can type it out, but you can think about it from what we said. What we said was the square root of a number times the square root of a number is the number, right? So that's your hint. Okay, so what did I do here to cancel off the radical? What's the name of that? You guys remember? Okay, what I did was I just squared it. Okay. And so if you have something squared, then the opposite is the square root. And you can see this isn't well visualized right here. That's right, radical. Good job. You can write this another way. The square root of 2 squared is that. It just cancels. It just cancel. And that's the way I write it when I cancel these two, okay? And so now we started with 4, now we have 6. We have multiplication, addition, division, subtraction, square root, and squared. And so it's the same rule, you're just going to use the inverse, and you've already dealt with radicals a little bit. And now we're going to apply them to an equation in order to solve for the variable, okay? All right, any questions about this? Okay, so let's clear this off and let's see an example, okay? And I wanna start off, I'm not happy with how much it starts us there, but let's say that we have, for example, this, yeah, the square root of, that's not where I want to start. I want to start off with x squared equals 4. Okay, let's start with that. So here's our equation. If I said, hey, x squared equals 4, solve for x. All right, so you're going to solve for x. Well, how do you know what x is? Well, we use the inverse operation. What's the inverse operation? The inverse operation is the square root. Square root. And it's just going to cancel that to x. Ta-da. Okay, now here's where it's going to get a little different, okay? I know that the square root of 4 is 2, so I can do that. But also, when you take the square root, you have 2 possible answers, all right? You have, and this is like right here, that's your clue that you have 2 answers, because not only does positive 2 work, but -2 times -2 is also equal to positive 4. So what numbers squared would equal 4? And that is positive 2 and -2. And they use this symbol right here. It's a plus and minus right on top of each other. Now you can also write it as x equals 2 and comma -2. You can write it that way, but this is the common notation right here. That's what they want. Okay. All right, so let's do another one. Hopefully you guys are writing this down. What if we had 2 times x squared equals 16? All right. So now we're still going to do the same thing, but before we can take the square root, we need to isolate the variable. Okay. So this is 2 times, so we're going to do inverse operation. And then that'll cancel. X squared equals 8. And then now I'm ready to take the square root. And that cancels. X equals the square root of 8 is broken down 4 and 2. And this becomes 2 root 2. And that is an answer. Okay. All right. The next one is going to be 2 times x squared plus 4 is equal to 16. Sorry about the 6. Okay. So this is just like our 2-step. This is a term with multiplication division, and this is a term that's added in subtraction. So remember, we're doing opposite PEMDAS. All right. -4 bring down the 2x squared. And I'm sorry about the 2. And now it looks just like on the left. So you have to use the same algebra you've used on linear equations, and now we're on quadratics. And so you're still going to do the same thing. Then divide, and then it's x squared equals 6. And then square root, cancel, cancel. X is equal to the square root of 6 does not simplify. And that's it. All right, so it's the same inverse rules. There's just now one more possible step. So remember with PEMDAS, we used to deal last week with exclusively with add and subtract and multiply and divide. And now we're getting into that P and E part of it, where you have an exponent and parentheses, okay? All right, any questions on this? You guys good? Feeling good? Feeling awful? There's lots of time to practice. Okay, let's do one more where we have square root of x equals 4. All right. So now we're going the other way. We're starting with a radical and we need to cancel the radical. So inverse operations, just like we use square to cancel, just like we use square root to cancel a square, we're going to use square to cancel square root. So what I'm going to do here is I'm going to say, okay, I've got a square root. What's my inverse operation? Squaring. So I can square both sides. I can square both sides. And what that's going to do is that's going to cancel off the root. And now I have to apply this 4 squared. And that 4 times 4 is 16. And one of the mistakes some students make is they say 4 squared is 8 because 4 times 2 is 8. Very easy to say that, especially 3. 3 squared, everybody wants to say 6. But take your time, and it is squared, okay? All right, same thing there. Let's see what delta math is going to give us. And I don't like how it jumped. I just did delta math just for ease of grading this year. It's going to give you this. And it's the same thing. Don't fret, okay? So go ahead and write this down. And remember, our rule is we have to do things to isolate the radical or isolate the term with the square, the variable with the square, okay? All right, what I want to do is I want to do PEMDAS backwards. So before I square this, I know I'm going to square this. I'm going to clear off everything outside the house. I want to get the yard looking good before I deal with the house. Okay, so I've got the yard cleaned up. Then after I clean up the yard, I'm going to take off the roof. All right, how do I take off the roof? By squaring it. That's going to cancel this. That's all it does. It just cancels that. So x plus 67. If I were thinking about the PEMDAS backwards rule, this would be your parentheses. So I've done addition, subtraction, and I've done the exponent, and now I've done now I'm going to do the parentheses. So 8 squared is not 16. Please, please, please do not write 8 squared as 16. Take your time. I know you see the 2 and you're like, just double it. Hey, 2 squared is 4. That means I multiplied by 2. And now that the last step is just to get rid of the 67. That's it. And x is equal to -3. Okay, all right. How are we feeling on this? Can you guys give me some feedback? Are we feeling intimidated? Are we feeling good? Okay, somebody says good, good. Okay, and if you feel a little intimidated, that should be natural. Okay, this is I don't know what your algebra background is. I didn't have you guys for algebra 1, but in algebra 1, you might have gotten this. I don't know if the pandemic messed it up, but we're following the rules. We're following the same rules. We just added 2 operations. Okay. All right, so I'm going to clear this, and I'm going to go here. And I'm just going to do this one really quick for you. So if you want to write this one down. Okay, so clean the outside of the house first. And that cancels. And see, it just gets brought down. And then the other thing is when kids square both sides, they do not know what's happening inside of the radical. They're like, I squared it. What do I do with all this? Nothing. Do nothing. All you do is cancel. Okay, don't think like, oh my God, I squared it. I got to do arithmetic on the left. No, you don't. There's no arithmetic when you cancel these out. It just gets rid of the roof. Roof. 9 squared is not 18. Okay, all right, now 3x plus 108 equals 81. We're back to 2-step. We are back to 2-step. Easy peasy. Gotta get out my calculator because 81 minus 108 is what my son is studying, and I haven't done this since 3rd grade. Can anybody do that in their head? -27, and then divide by 3, and x equals divide by 3. Negative divided by a positive is a negative. There you go. X equals -9. Okay. All right, so it does get a little bit big, and it's not a big problem set. I think it's like 5 to 7 problems. So take your time and write it out. I think this is great in keeping you organized. You need a straight river. You need to show the steps. You need to see this canceling out in your brain so you don't get messed up. If you want to talk about training your brain for situations where you have to learn things, I think this is absolutely amazing for that. So when you are asked at a job interview, hey, you have to do this, this, and this, and this. Can you learn this? You can say, well, I survived Mr. Brooks' Algebra 2 class. Of course I can do that. Okay. So the steps: isolate the radical or variable, square root, and if you take the square root, you need 2 answers. This one is the one where we're going to need 2 answers. Okay, so take a minute and write this one down. This is our last one. I know we're getting on 8:41. I know it's a long class, but this is our last one. Okay, let's see. I need to get off this. All right, does everybody have this written down yet? I'm going to read the math sentence because a lot of students struggle with the vocabulary with this. Oh, and I've gone so long. I have feedback for your tasks. That's right. I was going to talk about the tasks today. I'm not going to go over. I'm going to go over it just a second, but I'm not going to spend too much time because I'm going to get you guys out of here in 8 minutes. Okay. All right. So what do we do? Well, we follow PEMDAS backwards. PEMDAS backwards. PEMDAS says we start with addition and subtraction. PEMDAS, addition and subtraction. So clean out the outside of the house first. Not multiply first. 2x plus 1 squared equals, this is 44. Okay, now we did addition and subtraction. Now we're going to do multiply and divide. Multiply and divide. Some people are going to take this 2 and they're going to see the parentheses and they're going to say, I'm going to distribute it. No, you don't. That is not following PEMDAS. In PEMDAS, you must apply the exponent before you distribute. In reverse PEMDAS, you need to handle this too before you handle the exponent, okay? So if you were simplifying this, you would, before you would ever distribute that two, you would need to multiply x plus 1 times x plus 1. So in this case, we're going to divide by 2. Cancel. And this is x plus 1. Squared equals 22. Okay, so a common mistake happens right here. This is where a lot of students get stuck. They say, what do I do with this 2? I'm going to distribute it, and then the 2 is going to go away, and I'm going to be happy. But you have to follow reverse PEMDAS. Reverse PEMDAS. Add and subtract first, then multiply and divide. And now we're at the exponent. Here's the exponent right here. How do I cancel off the exponent? What's the inverse operation of squaring? It's square rooting. Put a hat on it. Some of my kids used to say, just put a hat on it, Mr. Brooks. That'll get rid of that. Okay, we'll put a hat on it. That's fine. That cancels off. What do I do with the x plus 1? Do I have to square it? Nope. Just goes away. This is going to make some kids uncomfortable because it's a plus minus the square root of 22. I cannot do anything to simplify the square root of 22. There's no perfect square, not 4, not 9, not 16, nothing goes into it. So it's just left alone. And then minus 1, I'm going to tack it right here. And x is going to be equal to plus or minus the square root of 22 minus 1. Oh, you know what? I said I was going to read the math sentence. I never read the math sentence. The math sentence is 2 times x plus 1 squared minus 17 is equal to 27. So 2 times the quantity, or 2 times x plus 1 squared minus 17 equals 27. And that's how to do that. Now you're going to get this answer in 2 parts. You're going to get part A, and you're going to get a part B. Okay, it doesn't have to be plus. I mean, it doesn't have to be minus. I'm going to put plus right here because B could be negative. But your answer is going to be, where plus or minus the square root of A, and then another part. Okay, so you're going to have a radical and a constant, and you cannot combine those two. Okay, so just leave it like that. How do you know when to put a plus or minus in front of the problem? Thank you, Mackenzie. Good question. If you square root, if you use this, then you have 2 answers. Or another way to think about it is if you have this in the problem right here, that 2, you're going to have 2 answers. Okay. Well, if you solved x plus 1 equals 27, you have 1 answer because there's a 1 right here. And if you have x squared plus 1 equals 27, you see this exponent right here, you have 2 answers. You have 2 answers. And if you have a square, you're going to have to square root. So therefore, anytime you square root, you have 2 answers. Okay, the tasks. I graded the tasks, and the tasks were really good. Like I was really happy. The scores were generally between a 7 and a 10. Okay, I thought if you did the problems correctly on the third parts, you got a 10 most of the time. If you correctly identified one thing that Amy or Ben did, you got a 10. You got a high score. If you were missing some parts of that, you didn't get a 10, but you got a 7. You can resubmit that. I posted a video inside the assignment. Let me show you. I didn't. It's also in the video docs, I think. But if you, oh no, you didn't have the task. You had the quiz. I'm sorry. I'm thinking of Algebra 2. Algebra 2 had their task. See, okay, you did not. I did not grade your task because you didn't have a task. You had the quiz. If you want to resubmit the quiz, did anybody resubmit it? Yes, 3 people turn it in. Okay. If you want to resubmit the quiz, you can. Okay, if you didn't get a good grade, you can resubmit the quiz and I'll bump your grade back up. You can get full credit. Okay. If you want to do the quiz with me, I'll do the quiz with you and you can turn it in. Or if you want to do the quiz with Miss Culver, I'm sure she'll do it too. Um, I am not up to date with the grades and I am so sorry. I've been getting some other stuff together and dealing with importing, and I am very confident that by tomorrow, if you have a poor grade in Infinite Campus, I can get that fixed for you, okay? So I apologize for that. It will come. And I know that sometimes like early on, you have a few assignments and one thing can like really squash the whole grade, but it's early. There's going to be lots of grades in the grade book. And pretty soon you're doing an assignment poorly or making a bad score won't have a big effect on you. But equally so, if you're doing really poorly in the class and you turn in a good assignment, it also will have a small effect. And so, you want to keep up with it and do a good job. If you got a 7 out of 10 or an 8 out of 10, I would say, if you have a little bit extra time one night, it's worth your time to see if you can get it. And again, if you want to touch base with somebody in the class and say, hey, what'd you get for number 3? I definitely encourage you to do math together. Okay. All right. Any last questions before we go? All right, I'm going to hang out for 5 minutes. So if you want to stay on and share your screen with me for anything, I do have Algebra 2 coming up at 9:15. But if you want to